So, grade 11s, please take note of the following. I want you to look at the table here that I've drawn for you. If you look here, you will see that there's hydrogen bond, and then there's all energy numbers inside here. C2H 414, O2H 460, and NH 390, CC 347, O2, O 499, C2O, double bonds, those ones 799. And then, of course, the last one, I need to fix it there. There's something that is missing in that one. So this is supposed to be nitrogen. Okay, so nitrogen is missing on that one. So that is 946. I want to explain what this means. It simply means that if we look at the first one, when we go to hydrogen, to break this bond of hydrogen, you need 436 kilojoule per mole of energy. C2H 414, then we can say the rest about it. So that's basically what these values are about. But then the question is, how do you apply this? We look at the question that is given to us here. The question says calculate the overall energy change, right? So and then remember, in terms of chemical reactions, energy is used to break old bonds, then energy is released when new bonds form along the product's side, right? So the equation is balanced, but you need to make sure that you balance the equation first before you engage in this particular calculation. Now, without any waste of time, I'm just going to break down the bonds and show you exactly what exists here. If you look at the first one, you will see that there's a bond between hydrogen and hydrogen, right? See that? And then look at the second one. There's a bond between iodine and iodine. Oh, sorry about that one. Let's take it off. There's a bond between iodine and iodine, which needs to be broken. And if we expand the arrow here, you will see on the other side that there's actually a bond between hydrogen and iodine, but there's two bonds. So which simply means that you have an H2I bond, right? Plus then another H2I bond. In actual fact, that's what that 2 simply means. It means that you have 2 times the bonds of HI. Now, we come back here. Then now we need to calculate the energy on the reactant side. So we say we need energy on the change on the breaking of bonds. That's what we need. So energy change on breaking of bonds. Then we write that down. So it's energy required. So energy change on breaking of bonds. Now remember, of course, these are old bonds, né? So we need that energy change on breaking of bonds. Energy change on breaking of bonds is very easy. It's a combination of the two. So look at it carefully. So we say energy in relation to this bond here plus, right? And then energy in relation to the bond of the 2 iodines, right? Now, if you look at this carefully here, we now need to go back to the table and see the hydrogen to hydrogen, we need 436 kilojoule per mole to break this bond. So there it is. Then we go and do what? We go and substitute. We say, okay, we need 436, right? Kilojoule per mole. And then we say plus. Then when it comes to the iodine, then we go back to the table again and check. Unfortunately, in this one, I do not have the iodine in that table, but I'm using another table on my on the wall. So that one requires about 151. Then we add this. So when we add this, it's going to be 436 plus 151. 151. Then we get 587. So that's 587 kilojoule per mole. Now that's the energy that is required to break old bonds. 587 kilojoule per mole. Then we move on to the side of the products. We are making new bonds. When new bonds form, so we now need energy change on that. Then we say, now go with me, please. So we say energy change when when new bonds form. Okay, not forms, form. Right? So now we want the energy change that occurs when new bonds form. And then I take you again, we have the energy of the H2I, that's the first, plus energy of the H2I as well. Then we go to our table and check if the H2I is there. I unfortunately do not have it, but I will pick it up from another source. So this is a 298 plus a 298. That's kilojoules. So then of course we add those two. When we add those two values, we have 298 plus 298. Then that will give us 596 kilojoule per mole. Okay. Now, when we want the overall energy for this, like I indicated at the end, the overall energy for this, energy change, energy change is then calculated by, remember, it's change in enthalpy. It's the sum of the changes in enthalpy of bonds broken, right, minus the sum of change of bonds formed, right? So what you have here is that we take it's 587 kilojoule per mole minus 596. Then we get the answer. So 587 minus 596. Then we get minus 9. Minus 9 kilojoule per mole.